Okay, so this is homework 1. This is the plots part. 5.1, you have x squared plus y squared equals 1. I took these n and m values, set them to equal 100. Then I set my lens space here from -5 to 5 to create my window. And then use my z value of m and n to help create this double for loop for the different values. Inserted my equation in, subtracted the 5 over from, why is that 5? I have no idea what this is 5. That has to be 1. And then my levels are 7, but if you do that, you get this graph here, which shows you the different contours and the levels of each contour. Okay. And then 5.2, it's the same thing, just with a instead of a circle, you're creating a slope of -1 starting at a specific number. So I just set my specific number to be 2, so it's not just going through the origin. And then if you don't put any coefficients in front, you're just going to have a 1 by 1 slope. And then same thing as before, with these values here, the lens space to set my window, and then the 0 here to use the for loop with my equation. Levels is 7 to show you different lines, contour, plot here. Then if I run this, you get these different levels showing you a -1 slope going from the left side to the right. And then 5.3, it is a x minus y graph equals 2, so you want a +1 slope. And it's going to make a straight line with a slope of +1 to a specific point, so it's going from left to right, going upwards. It's the same thing, the n and m values to use in all of these loops, the lens space to create the window, the zeros to let me fix that. The z equals 0 is here to use within the double for loop down here. And then it's just going to create pretty well the same graph as before, just the opposite direction. And then the x times y equation of 5.4 creates a hyperbolic curve. There's a changing discontinuity depending on the number it is set to equal to. So I set it to equal 1. Use the same n and m values. The lens space, I used the -10 to 10 window to show these different hyperbolic curves. It's the same for loop as before, different. I changed the equation to be what I needed it to be. And then 7 levels to show you the different curves, and then contour plotted it here. And then it looks like this. So that discontinuity is what? That's like around 1. And then 5.5, I could not figure out how to do the graph of x in a contour plot, as it's only one variable and the contour plots require 2 variable inputs. 5.6, it's an exponential graph based on the level input with x squared minus y equals 1. Same stuff here, the window is 0 to 5, and then same loop, just changed my equation down here to be what I needed it to be. And then its graph looks like this, so you can really see that exponential curve here. If I change the window from -5, -5, you can, oh, never mind, those are parabolas. That's cool. So it's a sideways parabola. Then for optimization, let me pull up. You have this contour graph here that I use to find the peaks and valleys of the predefined MATLAB function. And then there are 5 peaks and 6 valleys, so 1 peak here, peak here, peak here, peak here, peak here, and then all of these in here are valleys. So there's that, and then 2.2 and 2.3 are min and max on the constraint of a negative 1 to 1. So that's the wrong one. Here's this, your constraint at negative 1. And then the minimum here, I'd say, is around this area, with the max being around here at y equals 3 and x equals negative 1. And then the min being around negative 1, 3 is, oh wait, that's the wrong one. Around x equal to negative 1.121 with a level negative 2.65, and then the max being around the level 2.77. And then here is the same thing with a different graph with a constraint of a circle. So the local maximum in here would be, like, the minimum here would, on this graph, would be around the level 0.1, with the max being around 3.07, or I guess the min could be here at negative 0.97. Oh no, negative 1.01 is the actual, is another local minimum. So here, here, and here are local minimums, and then here's the local maximum, here's the local maximum, and then up here's the local maximum. And then this is the local max and min for another circle, but with a larger radius. So the circle's right here. And here would be a local maximum, and here would be a local max. Here's a local max. This is a local minimum. This is a local minimum. This is a local minimum. And all of these in here are valleys. And then that is my assignment 1.